Good morning students. Welcome to today's class. In previous class we discussed refraction through a concave lens. In this class we are going to discuss another topic, refraction through a concave lens. Let us discuss the formation of images by a concave lens when the object is placed at two possible positions. The first position is object at infinity. When an object is placed at infinity, that is far away from the lens, image is formed at the focus. In this picture, we can see the image is formed at the focus when an object is placed at infinity, that is far away from the lens. The image formed at the focus is a virtual image. Virtual image means we cannot see a real image. That is known as virtual image, and the image is smaller than that of the object. The second condition is when an object is placed anywhere at the principal axis at a finite distance from the lens. When an object is placed at a finite distance from the lens, image is formed between optical center and focus of the concave lens. In this picture, we can see that the object is placed at a finite distance from the lens AB and the image is obtained between focus and the optical center A dash and B dash. The image obtained is also a virtual image and the size of the image is smaller than that of the object. If the distance between the object and the lens is decreased, then the distance between the image and the lens also keeps decreasing. Further, the size of the image formed increases as the distance between the object and the lens is decreased. This condition is explained in the figure. Here, the objects are represented in the red arrow and their respected images are represented with the black arrows, which is near the focus of the lens. Here we can simplify it in this tabular column by seeing that the two conditions of the position of the object. The next one we are going to discuss is lens formula. This lens formula gives the relationship among distance of the object, distance of the image and the focal length of the lens. It is expressed by the formula 1 by f is equal to 1 by v minus 1 by u. It is applicable to both convex and concave lenses. The next topic is magnification of a lens. It is defined as the ratio of the height of the image to the height of the object. Magnification is denoted by the letter m. If the height of the object is h and height of the image is h dash, then the equation is m is equal to height of the image by height of the object, that is equal to h dash by h. It is also related to distance of the object and image, so it is expressed as m is equal to v by u. The next topic which we are going to discuss is lens maker's formula. For a maker of any lens, knowledge of radii of curvature of the lens is required. Lens maker formula relates the radii of curvature of the lens, the refractive index of the given material of the lens and required focal length of the lens. The formula for lens makers is 1 by f is equal to nu minus 1 by r1 minus 1 by r2. Here f is the focal length, nu is the refractive index and r1 and r2 are radii of curvatures. The next topic is sign convention. In this sign convention, we are having certain rules. These Cartesian sign conventions are used for measuring the various distances in the ray diagrams of spherical lenses. The rules are: the object is always placed on the left side of the lens. All the distances are measured from the optical center of the lens. The distance measured in the same direction as that of the incident light are taken as positive and the opposite direction are taken as negative. The distances measured upward and perpendicular to the principal axis taken as positive and the distance measured downward and perpendicular to the principal axis are taken as negative. The following figure represents the sign convention for mirrors. The blue arrows represent the positive and the red arrows represent the negative. The next topic is power of a lens. Power of a lens can be defined as the degree of convergence or divergence of the light rays. Power of a lens is numerically defined as the reciprocal of its focal length. P is equal to 1 by F. The SI unit of power of lens is diopter. It is represented by the symbol D. The power of convex lens is taken as positive, whereas the power of concave lens is taken as negative. Okay students, let's recall the concepts which we had learned in this section. In this section, first we have learned the refraction through a concave lens with two cases. Next we learnt about lens formula, magnification of lens and lens maker's formula, power of lens and rules for sign convention. Okay students, hope you had enjoyed the class. We will meet in another class with a new topic. Thank you students.